Hello, friends. Welcome to Nabila Mahmi Online Maths. In this video, we are to find the derivative of f of x equal to x cubed from first principles. To find the derivative of f of x equal to x cubed from first principles, the first step is quote the first principles formula. And the formula is f prime of x is equal to the limit value of h approaching 0 into f of x plus h minus f of x all over h. This is the first principle formula. And now, before you use this formula to find the derivative of this function, you can use the power rule to determine your answer before you start to work. And that one, we'll call it the shortcut way of finding dy dx. For example, if I have y is equal to x raised to the power n, and I'm to find the derivative of this equation, then dy dx will be equal to the power here will come and multiply x, and I'll have n x raised to the power n, and I'll subtract 1 from the power, that is minus 1. So this is what we call the power rule, and we normally use that one to determine the answer before we start to use the first principle. So for this question, we can say that y is equal to x cubed. Then to differentiate, we have dy dx to be equal to, this 3 will come here and multiply by x. It will be 3x to the power 3. Then we subtract 1 from the power. And this will be equal to 3x squared, because 3 minus 1 is 2. So the answer for this question will be 3x squared. But we have to use the first principle. And these questions normally come in the elective maths paper section B. That is the theory aspect. And dy dx is the same thing as f prime of x. They all means the same thing. So let's now start to solve the question using the first principle formula. So by using this formula, we can get our f of x from the question, because from the question f of x is equal to x cubed. So I can say that f of x is equal to x to the power 3. Then we can get our f of x plus h. To get our f of x plus h, it means that wherever we see x here, we'll put x plus h there. So here, I will now write x plus h all to the power 3. And we can expand this one using binomial theory approach, especially using Pascal triangle. It will be easy for us to get the coefficients and the powers of this expansion. So that means that using binomial expansion, that is Pascal triangle, f of x plus h will be equal to x plus h all to the power 3. And that one, the expansion will be x cubed plus 3x squared h plus 3x h squared plus h to the power 3. When you expand this, you get this. You know, the third power using Pascal triangle, the coefficients are 1, 3, 3, 1. So this is the expansion. I can now continue to solve from first principle by saying f prime of x is equal to the limit value or the limit value of h approaching 0, f of x plus h. And we know that f of x plus h is equal to the whole of this. So I can say that this is x cubed plus 3x squared h plus 3x h squared plus h cubed minus f of x. and f of x is x cube. So I will say minus x cube all over the denominator h. So I'll write my h there. To continue, my f prime of x will be equal to the limit value of h approaching 0. Here, x cube minus x cube, 0. It will go away. Then we have 3x square h plus 3xh square plus h cube all over h. And I'll close it. To continue, I'll have my f prime of x to be equal to the limit value of h approaching 0. Look at this, please. We have h. Here h square, here h cube. That means that h is a common factor. Then we can factorize it outside. So I'll have h outside. So if I take this h outside, here will be left with 3x squared. So I have 3x squared. Here, I'm taking one h outside. It will leave with 3xh plus 3xh. Here we have h cube, and I'm taking one h outside. It will leave with h squared. So here will be plus h squared, close, all over the denominator h. To continue, my f prime of x will be equal to the limit value of h approaching 0. This h will take away this h. We have h as numerator, h as denominator. They will cancel out. I will now have 3x squared plus 3xh plus h squared. To continue, since this denominator has gone away, we will now substitute h to be 0. Wherever we see h, we'll replace 0 there. And this limit or lim will disappear. It will vanish. That will be f prime of x will be equal to, the lim will go away. Wherever we see h, we substitute 0. So here will be 3x squared plus 3x multiplied by 0 plus h, which is 0. Then we square it. And f prime of x will be equal to 3x squared. 3x times 0 is 0. Plus 0 squared is also 0. So you see that here will be 0, here will also be 0. And finally, f prime of x will be equal to 3x squared. And this is the final answer. And like I said earlier on, if you are using the power rule, definitely you will get the same answer. And the power rule said, if you have y is equal to x cube and you have to differentiate, definitely it will be dy dx to be equal to this 3 will come and multiply x. It will be 3x. Then you subtract 1 from the power. If I subtract 1 from 3, it will now leave what? 2. And it will be 3x squared. And this is the shortcut way of differentiating functions like this. And we also said dy dx is the same thing as f prime of x. They all means the same thing. So the most important thing is that using first principle, this is the procedure, and your final answer for this question is 3x squared. Thank you for watching this video, and do not forget to subscribe to my YouTube channel, Nabila Mahmi Online Maths, for more maths video. Bye bye.